YouTube? We should be live any second now. Hello, welcome to my practice stream. If it's your first time, my name is John. I am a former math major turned software engineer, and now I am leaving my high-paid career, my high-paid, cushy career in software engineering to become a high school math teacher. I'm practicing mathematics here on the internet for fun because I love math very much. And today we are going to continue our journey in linear algebra. In particular, we are in chapter 9 on complex scalars. We're going to be working some problems about the algebra of complex numbers, matrices and vector spaces over the complex numbers, eigenvalues and diagonalization, and we'll see if we can get to the Jordan canonical form. I don't think we will today. But in any case, here is the first problem that we have. This is a fairly straightforward, simple one, algebra of complex numbers. So, some people yesterday had a really good piece of feedback, and I freaking appreciate it, man. Like, it is a saying that I always say in my guitar channel. Feedback is a gift. If anybody has any suggestions, any kind of feedback, I am always all ears. You can help me make this stream better. Like, how do I build a channel that you all really enjoy watching? How do I put out a better and better show all the time? Like, feedback is a gift. So somebody pointed out, like, oh, it would be really nice if you could always have the problem up while you're working it so that we can see what the problem is. I think that's a great idea. So today I just found that I can group this thing and I can move it around. So I'm going to try to see if I can always keep the problem visible while we're working it. All right, so without any further ado, let's get into it. Let's practice some math. So thanks for watching. Here's the first problem. Find z and z bar and verify that the product of z and z bar is the magnitude of z squared in these two different cases. So in part A, maybe I don't know, should we give these two different colors or something? Let's do blue. And we could also do red. So, in blue, when z is 3 plus 2i, magnitude of z is 3 squared plus 2 squared, and the square root of that. The square root of the sum of squares, which is 9 plus 4, so square root of 13. Z times z conjugate is 3 plus 2i times 3 minus 2i. And so this is going to be 9 minus 4i squared. 9 minus 4i squared is 9. Here, let's write that out. 9 minus 4i squared, which is 9 plus 4, which is 13. Therefore, I'll just say, and that this is the magnitude of z squared. Okay, and we're done. Yeah, let's keep it on the same line. Not that it matters, but equals 13 equals the magnitude of z squared. So that worked. Yo, how's it going? Oh, you're working conic sections, really? No way. And it has the conic sections have the highest weight on the JEE exam. I find that hard to believe. Are you serious? Yeah, conic sections are hard. They're just hard, I think, for me. I'm still learning them. So you could watch my stream from yesterday. I did a little bit about them. Not that much, but a little bit. Okay, so part B. How's it going, kinetic football dev? Any tips? No, I don't know. Not particularly. Ooh, complex conic sections. It goes over your head. I don't know anything about complex conic sections, I don't think. Um, yeah, I don't know, bro. That sounds interesting. So we've got the real part of z squared plus the imaginary part of z squared, and then we take the square root of that. So this is 4 squared plus negative 1 squared, and that's going to be square root of 17. Then z times z conjugate is, yeah, it's just simple right now, just the very beginnings of complex numbers. So the argument and conjugate of complex numbers, it's the absolute value of complex numbers, I guess, like the magnitude and the conjugate. Yeah, so fairly straightforward right now, but so z times z bar, z times z conjugate, 4 minus I times 4 plus I. So the conjugate, with the conjugate, you, let's say, z bar is the real part of z plus, minus the imaginary part of z, instead of plus. Instead of plus, we subtract the imaginary part of z. So we flip the sign. Like if the imaginary part of z was negative, then it's positive. It's good, builds basics for afterwards. Yeah, and it tries to keep these videos more self-contained and everything, and we systematically work through the whole book. Okay, so z bar. So if we multiply these, then we have 16 minus I squared, and that is 17, and that is indeed the magnitude squared. So we're done with that problem. All right, let me cross it out in my book. Done. Now we're going to move on to section 9.2. 9.2, find matrices. We're doing matrices over complex numbers now. So, solution. AB is, well, let's see if I can I capture still part of this group? Will this work? No, it copies the whole thing. Yeah, okay, that's what I thought. That's too bad. Okay, so that's a downside of how I, yeah, that's a downside of this, like, showing the entirety of the, showing the problem at all times. Hey, what's up, Mizzy? How's it going? Good to see you. So I guess I have to copy this again. 1 plus I, 1 plus I, 1 minus I, 1 plus I, that's annoying, 1 minus I, times minus 1, 2 plus I, 1 plus I, 1, 1 minus I, and I. Okay, so whatever that is, we can duplicate this, give ourselves a little bit of space, and rewrite where this will be b times a. Okay, so first, a times b. How's it going? Today, let's solve some inverse trig functions. No. Late today, kinda. I mean, I had a open mic thing with my guitar community. So, yeah, a little bit late, I suppose. So in this first element, we have minus 1 plus 2i plus 2i minus 1, because, yeah, we have plus I squared, and then we have minus 1. So I'm taking the dot product of the first row and the first column, so negative 3 plus 2i. Negative 3 plus 2i in that first entry. Top row, middle column, we have 1 plus I minus 1 plus I. So I think that's 2i. 1 plus I minus 1 plus I. Yes, that's right. And then in the top right, entry, we have I, 2i plus 1, 2i. Yeah. Middle left, how good am I at chess? I'm not very good at chess. I don't play chess. I played a little bit during the pandemic, but I didn't get too far. I like chess, and I think I could get pretty good at it, but chess is like a dedication. I like lots of board games. I'm a big board game fan, and I like other games more than chess. Like, if I were to get really good at an abstract game like chess, I would practice Go. I like Go a lot more than chess. Yeah, I like Go is really nice. Minus 1 minus I. 1. Yeah, just 1. Okay, it's hard to do these in my head. Okay, I'm not going to try. So, minus 1 minus I. We're doing this row dot product with this column right now. Minus 1 minus I, plus 2, plus I, and minus I squared, which is plus 1. So plus 1 and minus 1 cancel out. Minus I and plus I cancel out. So we're left with 2. Now we're going to take the dot product of that middle row and this middle column. We have 1 minus I squared is 2. 2 plus I minus I is 2. And now, oops, wrong tool. And now, middle row and last column, I plus 1, or no, minus 1 plus I, minus 1 plus I minus I, so we're at 0. and yeah, positive 1. I think that's right. I minus 1, yeah, 0, yeah, positive 1. Okay. Now we're going to do third row, first column. We have minus I 2. Oh, wait. Have I been messing up some of these distributions? I think I've been messing up some of these distributions. Dude. Wait, maybe? Have I? I feel like I may have messed up some parts of this. I'm going to restart. Sorry, everybody. Let's slow down. Because I feel like I may have messed up some parts. Minus 1, plus 2I, minus 1, minus 1. Minus 3 plus 2I. Negative 3 plus 2I. Thanks for hanging out with me and practicing some complex scalar multiplication. Please do like and subscribe if you enjoy this. And yeah, alright, so 1 plus I, 2I. Yeah, 1 plus I. No, yeah, minus 1 is I, and I plus 1 is 2I. Okay, so I got that. And I 2I plus 1. 2I plus 1 minus 1 is 2I. Cool. Hope y'all are enjoying this matrix practice. We've got negative 1 minus I, 1 minus I plus I is 1. 1 plus 1 is 2. Minus 1 minus I. Yeah, I think I got a different... No, I don't know if I got a different answer there. That sounds different than what I had before. We're doing... Like, I think that I got this distribution incorrect. Like, the product of two terms. I felt like I didn't correctly distribute in some places. So 1 plus I squared is 1 plus 2I plus I squared. Right? And then we have plus I minus I. So those two terms cancel. 1 and I squared cancel, so this is 2I. Yeah. And now we have I plus I squared plus 1 minus I minus I squared. So those two cancel, this and this cancel, and this is just 1. Minus I 2 plus 3i 2 plus 3i plus I squared, and plus I minus I times I is negative I squared, which is plus positive 1. Positive 1, negative 1 cancel, negative I and positive I. So this is 2 plus 3i. And now we have I plus I squared, I plus I squared, and what plus I squared? 1 minus I. So negative I, positive I, plus 1, negative 1. This is I, negative 1 plus I. Cool. And now finally, I squared is negative 1. This next term is 1 minus I squared. 1 minus I squared is 2. And I minus I squared, so plus I minus I squared is positive 1. Negative 1, positive 1 cancel out. This is 2 plus I. All right. I think we got A times B. It took a little while, but we got it. And now we're going to do B times A. You reckon you'll finish the book within 100 days? No, definitely not. No, I don't think so. I mean, no, 100 laps, yes, but no, we won't finish the book. There are, in this section, there are 45 problems. And if you count the programming exercises, which maybe we'll do someday, then there would be 56 problems in this section. So, I mean, I've gotten to every section. I think within 100 days, we'll have worked a problem from every single section in the book. And I'll have, understood the concepts from every single section. So if that counts, and working at least one problem from every section of the book, yeah. We're already very close to that. We're already very, very close to that. Okay, now B times A. Thanks for hanging out with me during this ASMR session, y'all. We have negative 1 plus 1 plus 2I plus I squared plus I squared. So this is negative 2 plus 2i. Then we have negative I plus 1 plus I plus 1 plus I plus I squared. So 1 and negative 1 cancel. Negative I and positive I cancel. We have positive I. Negative I squared, I, negative I squared. 2 minus I. Yep. Then we have 2 plus I plus I, 2 plus I plus I plus I squared plus I minus I squared. 2 plus 3i in that term. Yeah. How's it going, everybody? I hope you're having a great day. Thank you for tuning in. How are the audio levels, by the way? Do you want the guitar music louder or quieter, or is it the right level? How do you feel like? Would you like to have more music, less music? Cool. Almost done. That's what I got. So, let's see. Can we check the back of the book? Yes. Yes. This is an odd problem we can check. How did it go? Did we get it? Okay. Two I, 2i, 1, 2 plus 3i, negative 1 plus I, 2 plus I. Got it? Negative 2 plus 2i, 2 minus I, 2 plus 3i, 1 plus 3i, 0, 2i minus 1 plus I, 0. Got it? Okay. Did it. We did it. Now let's keep going. I don't yet have a problem written out for section 9.3. Let's write it out. Eigenvalues and diagonalization. Find a unitary matrix U and a diagonal matrix D such that D equals U inverse AU for the given matrix A. Hell yeah. Hell yeah. Now we're getting to some cool stuff. This is equivalent the spectral theorem over complex numbers. Find a cool. 1i minus 1i. Now, what I can do is I can group this, and hopefully we can see if we can keep this up on screen throughout the solution. Oops. I wanted to box it as well to give some visual separation from the solution. So what I can do, I found, so that I can convert this, and I can just move that around as I'm working the problem, if I remember to, if I get in the habit of it. If I change how I work problems to entertain you all here on YouTube. Okay, so we recall that a unitary matrix U is such that it's the equivalent of symmetric. Oh wait. Is it? It's the equivalent of orthogonal? Is that right? Is this correct? Okay. What is the definition of a unitary matrix? I think it's in the previous section, isn't it? Yeah, it's in the previous section. The conjugate transpose of an m by n matrix A is the n by m matrix A star equals a conjugate transpose. And in symbols, we can write U conjugate transpose like this. In symbols, the conjugate transpose, wait, what is this called? The conjugate transpose is this. Yeah. And then a unitary matrix is, so I got this correct. In particular, a real symmetric matrix is unitary. Or a real unitary matrix is orthogonal. Oops. A real unitary matrix is orthogonal. Right? Yeah, that makes sense because A conjugate equals A, and then if A star equals A transpose, then A star equals then A transpose equals A. Yes. Okay. Yeah. Makes sense. A transpose is A inverse, and that's the definition of a orthogonal matrix. Okay, so in particular, a real unitary matrix is orthogonal. So, I think that we compute eigenvalues the same way that we do in previous sections. And we normalize the exact same way as well. So we compute eigenvalues of A. The characteristic equation would be lambda minus 1 squared, or if I wanted to show this a little more directly, 1 minus lambda squared minus negative I squared. And this is lambda squared plus, lambda squared minus 2 lambda plus 1 minus 1. So, the roots of that characteristic polynomial are 0 and 2. Okay, so now here I can try my little trick that I've been looking forward to. In theory, let's see how this works. That's not going to work well. Because that's going to show up overlapping. Yeah. I mean, I can try to continue and just, like, leave a lot of weird, awkward space. Oh, well. Things I do for you, YouTube. Nobody's even watching right now, so whatever. Then the eigenvectors are v lambda 1 equals the eigenvector corresponding to lambda 1 equals 0, which is the null space of the matrix 1 minus 0 I negative I1, which is the span of the vector so I can see that these two lines are dependent. If you multiply the first line by negative I, then, well, negative I squared is positive 1, and then the two lines are identical. Hey, thanks, Ta. I appreciate it, man. Yeah. Yeah, you can catch the recital later, or you'll see it here many times, I think. Speaking of, I want to turn up the music just a little bit. Let me know if the music's too loud. I think it would be nice if we could just have music going and I'm not having to think out loud quite as much. But I don't know. Yeah. Span. It feels more open and welcoming if the music is louder. Okay, hell yeah. Great. Let me know if you want it even louder. I have no idea. Let's try to take it even further.
Can't I grab this? Weird.
Done. Cool. All right, we did it. We did a problem from this section. We did the first one. First exercise from this section. So we're making some progress. Making progress through the book. Let's take some notes from section 4. Jordan canonical form. Because I don't know enough about this. So in this section, I want to be taking notes. Hey, what's up, Alan? What's up, Alan? How's it going, man? How are you? Just chilling, taking notes. We're getting to section 9.4 for the first time today, so we're taking notes on this section. How are you doing, dude? I'm just kind of hanging out and chilling and doing a note-taking stream right now. You're good. Good to hear it. Alan, I forgot that. Yeah, you're primarily a guitar person, right? Yeah, I forgot. You come from the guitar stream, right? Or did you find the math stream and then the guitar stream? In either case, dude, tonight is my recital. If you can join, I would love to see you there. Recital, 8 p.m. Eastern time, New York City time, or midnight UTC. Yeah, hell yeah. That's awesome. Yeah, my spring recital. Spring 2026 recital. So, all of the pieces that I've been working on for the last 3 months. Ooh, 3 a.m. Yeah. Don't worry about it. Yeah. Well, you can catch the replay. Replay available later. So, ooh, El Cookie, nice job. You studied a bunch. Hell yeah. Happy to hear. Okay, I will keep reminding people throughout the stream about that. So we're going to show that this matrix is not diagonalizable. Hell yeah. I'll revise everything tomorrow and then practice so much with you. Hell yeah. Hell yeah, dude. Do you all think that we should have chat on screen with your beautiful music on? Aw, thank you. Tonight, I've got my recital, dude. Soon we'll have new music. We'll have new music here in the corner. So I'm looking forward. Only a little bit nervous. We show that I think that this is... Yeah, there's no need for chat on screen covering things up. Do you think that it should be a 50-50 split like this where the iPad is vertical over here? You can see like more text on the iPad, or the iPad could be horizontal and then let's see. This is my old attempt at this kind of format, where we could have the iPad be horizontal. You see what I mean, right? Like, do you think that it should be more like this? I think it's good this way. Yeah. I mean, just notice that we'll have like less text on the iPad, but it'll be more readable, I think, for you all. Would you prefer this mode or the other mode? This looks nice too. I do think that this is nice. You like this? Okay, let's try it this way. Let's try to go back to this format. Equally good. Okay. I think that this is nice. I don't like the way that the guitar thing is showing up right now, but I think that we can fix that over time. Hide the timers. I think if I shrink myself a little bit and get like a little bit of a black border between the to maybe get the jigsaw puzzle back in the background. We could probably, yeah, I've been wanting to try this layout again. Okay, so now let's just make sure that there's a little bit. I mean, my shirt kind of creates a black separation between the two videos anyways. Sorry, streamer stuff right now. Oh, you like this? Yeah, it looks quite nice. You prefer it this way? Let's go back to this form. This is how it used to be. Okay, and then you can see more math a bit better. I don't like it when the page thing shows up in the bottom right, but I guess it's fine. I'll just live with it. Okay, so show that that matrix is not diagonalizable. Yeah, you're right, everybody. We should go back to this. Sorry, it's taken me this long to go back to something that looks way better. Yeah, this probably does look way better. Yeah. All right, well, thank you. No, I don't really do rest days. Unfortunately, I probably should. I probably should do rest days, but I don't really do them. Some days I do rest days on streaming, but I practice math and guitar every day now. Yeah, every single day. Thanks for asking. Quarter rests, lol. Yeah, I take rests within the music. What's up, Zombie Salad? How's it going? How's it going, dude? Zombie Salad, doing good. Sight bleeding. What about you? I'm doing good. I'm doing good. I don't know if that was a typo or not. Are you having a lot of pain right now with your sight reading? And thanks so much, NJS16. Appreciate it. You are. You are. Thanks for answering. I do rest one day for my guitar practice, mainly because I'm lazy. Well, that's not a good reason. That's not a good reason. But hey, if guitar's just a hobby for you, you don't have to practice every single day, dude. You don't have to. In my younger days, lol, I'm still so young though, but I used to get fed up if not having rest days, still if it's my favorite hobby, so yeah, it depends on you always. Yeah. I've done a lot of work to build up habit formation. I believe a lot in like habit formation of trying to get to the point where you're practicing every single day, like no matter what, without fail. Every single day I'm practicing. And what's up, boy, if YP80085? How are you? Nice to meet you. All right, so welcome to my practice stream, everybody. I am practicing mathematics. Later. Holy shit, is this the same JC practices I saw in the Leo lectures chat? Yes, it is, dude. Yes, it is. We are working on complex scalars today. We worked a problem that showed we found a unitary matrix. We're doing spectral theorem sort of stuff. And we found a diagonalization, and now we're learning about Jordan canonical form. Y'all, shout outs to Leo Lectures. By the way, everybody, shout out to Leo Lectures. Shout out to JC Practices. There are two different JC Practices. That's important to know. But first, shout out to Leo Lectures. He started streaming. He's joining the dark side of mathematics streaming. I think it's awesome. You definitely should keep doing it. It's fun. What are my favorite books in math? Man, That's a tough question. Favorite books in math? Probably like abstract algebra books, like Dumb It and Foot, honestly. Like I really like Dumb It and Foot. It's just nice. I mean, it's very encyclopedic, I guess, but it's a really nice book. I love that subject. Abstract algebra is beautiful to me. Um, yeah, I'd have to think about it. There are others. I've got a lot of I've got a lot of math books. I like this linear algebra book a lot. It's like a really nice introduction to linear algebra. It's not the most rigorous. I mean, it has theory. It is very conceptual. It's like as if it were a math book written for somebody who's going to become a math major. Hey, dude, I enjoyed your recital. Thanks, Nizam. Thank you, dude. That you realize that was my winter. That was my January recital, right? I don't know if you realize that. But what's up? What's up, Nizam? Good to see you, man. Yeah, that was my recital from January. Tonight, I will be running my spring 2026 recital. And the one that we're listening to right now is my fall recital, it looks like. Ooh, jcpractices tabletop when? Good question, dude. Funny that you would ask. Yeah, I geek out about tabletop, dude. I do have a jcpractices gaming channel where I'm very much considering that. I could become now the one you uploaded last night/day. So I don't know what you're talking about. I didn't upload the one that you watched and you commented on. That one's been available for a long time. Hey, thank you, El Cookie, thank you. I appreciate that. Yeah, the one that you commented on has been available since January. Actually, I ran that live stream in January. The one that I'm running tonight in 8 hours, 7 hours. Oh my god, I have to practice. In 7 hours, I will be running my next live quarterly spring recital. So if y'all can join, I would love to see you there. But yeah, Alan, like that gaming channel is it's pretty new. I haven't done very much in it. I've done some Rhythm Doctor, but I've definitely thought about gaming and doing like, you got a Discord notification yesterday about a recital. I think I was notifying that tonight I will be having my recital. I was notifying, just telling people like heads up, tonight I'm running a recital. Yeah, if you click the link, then there was a link to the actual one. It's yeah, if you clicked the link, it was linking to this, which is still coming up. Slay the Spire 2. I've heard that it was good. Yeah. Could have just streamed this. That's the thing, dude. I was thinking that yesterday when I was playing Earthborn Rangers. It's like, once you start streaming, you start being like, damn, I should stream everything in my life. I should stream everything. But yeah, Nizam, I'm glad that you watched the old one. But yeah, we're going to do a new one tonight. And I know that it'll be super early for you. But yeah, thanks. Okay, so yeah, let's keep going. Let's examine this matrix more. Hey, take care, Ta. Great to see you, bro. Great to see you. Okay, last thing. Somebody asked about tabletop. I would love to stream like a solo tabletop stream. Like if people want that, I think that would be amazing. There's one called Earthborn Rangers. It's so beautiful. It's such a beautiful game. It's like a very cozy solar punk version of Arkham Horror, the card game. Hey, take care, Leo. Great to see you. Everybody should follow Leo. He's an awesome math streamer, fellow math streamer. Yeah. If people want it, we could definitely think about restarting the gaming channel and focusing on rhythm games and tabletop games, I'd say. But let's get back to the math. Yeah, there are people out there who love it for sure. One of the people who's like a semi-regular in my channel's Tim. He's like small time influencer in like board games. Like he and his brother have like this company and they're like little mini influencers and tabletop stuff. Yeah. All right, I'm gonna work this, take some more notes for a bit. Hey, dude. Take care. Take care, Lukuki. It's great to see you, bro. And Nizam, if you're still here, we missed you in the studio class with Chris. We missed you during that open mic. I was the only one who was there. It was me and Garrigon and Chris. So, yeah. All right. Yeah, dude. If you can catch the recital, it would be awesome to see you there, but no pressure at all, El Kuki. Good to see you. Yeah, man, I'm not sure how you missed it. We've got I posted reminders in the Discord, and we've got the calendar event, and it's always at the same time every week. So I don't know. Have you ever got stuck in a piece for too long? HVLP4 is doing that to me. I'm overly obsessed with the evenness and tempo. Yeah, I don't know. A lot of these pieces take a lot of time to really do well. I'd say it took me, I don't know. Like, I worked on that for one of my exams a while ago for RCM 6. And so I worked on that one for like a year to get that one smooth back then when I first learned it. Yeah, it's alternating. I mean, yeah. And I've mentioned it in, streams and stuff like that as well. But yeah, it happens. take care, Nizam. Yeah, see you around. Hope you can catch the replay of the recital. Good to see you, dude. Take care. Yeah, I mean, I feel like if I'm not chatting as actively, we probably dip in engagement. Like we probably just drop a bit in terms of people feeling invited to chat. So please do feel free. Please do feel invited to drop comments or drop thoughts. I don't know. Like it is a study session, but it is also hanging out, chatting, and everything. Like I'm just not sure. I'm not sure. Maybe if the music is louder, then these study sessions are a little more rewatchable after the fact. I have no idea. I have no idea if people would want to like study to these videos. Cool. exercise, but we're not done with all of the examples. Let's work the first exercise. Yeah. Let's just do the first exercise and then we'll call it a day. So the first exercise from this section, which is called Sorting canonical form. Yeah, I don't know. I don't know about having the music loud or in the music as background music. Y'all should give me some feedback. Let me know what you think. Would you prefer to have louder music or quieter music? Should I be yapping or should I be just focusing and mathing? I could see either approach. Hmm. Okay. Okay, I feel pretty good about this. We've just done 5 exercises from this section. So I usually just do one, but these were all so quick that I thought we may as well just do a bunch all at once. Thank you for watching, everybody. I hope that y'all were able to get some studying done or whatever it is that you're trying to get done today. Thanks for watching. If you're enjoying this, please do drop a comment in the comment section. If you're here live, honestly, if you drop a comment in the comment section afterward and just say thanks or something, or like really enjoy these or something, it helps other people who find the VOD know that, you know, that there was community hanging out here. It'll help, you know, the algorithm push it out to more people and all of that good stuff. So thanks for watching. But if anybody's watching the VOD, please let me know, because I really don't know if these videos, if anybody's watching these videos all the way to the end. Probably not, but, you know, who knows. All right. Thanks for watching. I gotta go. I have a recital tonight, and if anyone wants to join the Discord, it's a nice little chill community. It's a really nice little chill place. So, thanks for watching. It's been a pleasure today. It's been a pleasure to hang out and practice with you all today. I gotta go. Bye. Bye.